I've decided to replace my existing NAS with one that can support 10 gig, but after looking at the various vendor options that are out there, I've decided to actually build my own. So what was it that actually swayed me into deciding to actually build an actual NAS from scratch rather than buying an actual pre-built one? What hardware did I actually choose? And what's the actual performance on this thing like? Well, if that's something you're interested in finding out, then stick around and watch this video, because that's what we'll be going over. Now, I will include chapters in this video in case there's a particular section you just want to jump straight to, but I thought I'd begin with an explanation as to why it is I'm actually going to be building my own NAS. And the reason is this: it's ransomware. It's becoming more popular. Now, although I can see the vendors, they've got a vested interest in trying to mitigate this. They are taking steps to try and avoid you actually getting into this situation where your data gets encrypted and then you've got to pay somebody to actually get your data back, for example. What concerns me is the potential direction that this could be going in, because whereas in the past my priority was probably cost, it's a case of it would probably be cheaper for me to actually purchase a pre-built NAS rather than build my own from scratch. It would also probably be cheaper to actually keep it running 24/7 as well. But now security and stability are much more important to me. Now, one of the reasons I'm deciding to build my own NAS is because of the potential that these vendors could go down the path of automated software updates. I've already noticed, for example, in one that I've got, where they introduced a new feature where the actual NAS will update itself by default. So when a new patch comes out, it'll download it, install it, and then it'll reboot. There is an option to disable that, but if they decide to change it so that it's mandatory going forward, and bear in mind these vendors, they do have a vested interest in every NAS out there being up to date, well, why not actually mandate that? Why not force you to keep your system up to date? Because this is having a big impact on their actual reputation, all of these problems. It puts people off buying their particular NAS, for example. But for somebody like me, that's a big problem. I mean, I've been in IT for a long time. I mean, I certainly don't allow access from a public cloud to my NAS or anything on the internal network if I can help it. And I certainly don't allow direct access from the internet. So I'm already at reduced risk of these ransomware attacks anyway. But if they go down this path of forced security updates, that's going to have a big problem for me, because I don't just store data on the actual NAS. I actually store encrypted data on the NAS. And it means that every time the NAS reboots, I've got to give it the key, it's got to decrypt that data. So it's a bit of a pain, I must admit, every time there's an update. But all the same, I do want to still keep it up to date, but I want to control that. I want to make sure that the software's been out long enough before I apply it to make sure I don't break something, to make sure that that NAS comes back up and is still working, that the applications are still working. You've got to give it time, you've got to test it first. Another risk I run is that if they force a software update, the NAS will reboot overnight, and that's going to impact my virtual machines. It's going to basically break them and potentially corrupt the actual hard drives on them. The reason being is that I'm actually using the NAS for shared storage. So I've got hypervisors that use shared storage on the NAS, so they're actually directly connected to the NAS, and if the NAS just reboots because of a software update, all of a sudden those virtual machines will just stop working. They never had a chance to do a clean shutdown, for example. So it's always best to have a controlled software update. Test everything first, then you roll the actual changes out. And in the case of retail sort of stuff, you just wait a certain time to see if anybody in the media has reported any bugs. If not, then you apply the latest change yourself as well. So that to me is a big risk. I'm not saying it will happen, but the trouble I'm going to see is that if I actually purchase this hardware that's got the actual software with it, that's it. I'm going to be stuck with this stuff for however long, probably quite several years. The latest actual NAS I've got, it's over 7-year-old. It's that stable. And the problem is that I don't want to be in a situation several years down the line, or even next year, where all of a sudden, well, I've now got these mandatory updates. So that for me was probably a big deciding factor. Now, another thing that's influenced my decision is the use of firewalls on the NAS, or more specifically mandatory firewall rules. Because before this whole ransomware problem actually started off, your typical NAS didn't even have a firewall in the first place. And that makes sense because you put a firewall between the NAS and the actual PC. you're just going to slow down the data transfer. Your uploads will be slow, your downloads will be slower as well. So there are recommended standards you're supposed to be taking where really the only computers that have access to the actual NAS should have direct access, everything else should be blocked anyway. Now, I can see from the actual vendor's perspective that they're thinking more in terms of your typical retail user. Let's put a software firewall on there, in which case we'll help protect them from direct internet access, for example. So that did make some sense, I suppose, initially, but one thing I've noticed was in a fairly recent actual software update, there's a rule right at the top of the list to allow access from the actual cloud pole. Now, fortunately for me, I've got firewalls that sit in front of the actual NAS in the first place, and they certainly wouldn't be allowing access from the cloud pole. So technically that rule's not a problem. But the problem for me is the fact that it's a mandatory rule and I cannot get rid of it. If, for example, I were to make some sort of like mistake on my firewalls and allow access for some strange reason, all of a sudden there's the potential there for somebody to get access to the cloud pole. I don't want that. If I want to have a secure NAS, I actually want to be in control of my actual firewall on it. I want to be in control of the actual security of the actual NAS itself, and I don't want to allow access from anywhere unless it's direct access. But they've got a rule sitting right at the top of the list to allow access from the cloud pole, and I cannot remove it. So that, to me, from a security perspective, is a big no-no. The sort of the recommended mantra, if you will, is least privilege. You should only be allowing access to things if they are necessary. In my case, that is not a necessary requirement, but I cannot take that away. There is not an option to remove that rule, at least one that I can see, and so I'm stuck with it. So again, that's basically a case of, that's it. I just do not want software like that if I cannot control the security on it, because I've no idea what else they might introduce later down the line either. Now, another thing that made me sit up and think when these ransomware problems started was the actual software that's forced upon you when it comes to these NAS solutions from vendors. I mean, you get a NAS, which normally would just be a NAS and that's it, but there's a lot of different little applications that come with it. Now, over the years in IT, what I've noticed is there's been a slow sort of like movement towards including software with an actual computer system. But it's up to the actual end user whether they actually want to use it or not. Now, in the case of these particular NAS solutions, well, there are actually certain applications that you cannot uninstall or disable. So we're talking about things like maybe a media player, for example. Now, if I just want to be a NAS to be a NAS, it's really in my interest to actually turn that actual media player off, for instance. The reason being is, over the years, what's been learned in IT is that you really want a more modular approach. It's kind of like similar to the security mantra of like least privilege. The idea is, if you've got software on your actual computer but you don't need to use it, don't run it. Two reasons. One is security. In other words, if you've got some software on your computer, some application that's got a vulnerability that could allow somebody to take remote control of the computer, well, if you're not actually using that software, then you're not at threat of that actual risk. Similarly, if you're running an application that's got an actual bug in it, that bug could lead to, for example, a memory leak. It could lead to the computer crashing or rebooting. But if that happens to be a piece of software you do not need and you're not running it, it's not going to affect you. So in hindsight, over the years, that sort of advice really made a lot of sense. And when you look back, if you don't actually need any software on your computer, then don't use it in the first place. But what we found with these ransomware attacks is some of that actual software that actually gets forced upon you did actually have vulnerabilities in it. Now, if you've been following the actual recommended strategy of not running software if you didn't need it, that sort of thing reduces the risk. So that's something else that really got me thinking, well, I'm not going to have much choice over some of these software applications running on the NAS. Aside from the fact it just wastes resources, it increases the actual security threat and the stability threat. I should be really using software that I can control, but these NAS vendors don't let you. Well, I'd say my final decision was more of a benefit really, and that's to do with the flexibility I'll get. In other words, with your typical NAS, you're not going to get that much options when it comes to actually upgrading the actual computer. Usually you'll find that the actual CPU is an embedded one that's built into the motherboard, meaning you can't upgrade it. there's probably a low limit in terms of how much memory you can actually put in it as well. And you've only got a certain amount of room for actual hard drives. Now, there are systems out there, for instance, that allow you to add NVMEs in, for example. There are some that allow you to add external hard drive cages, but you've got to pay for those sort of things. They're much more business, professional orientated ones. But if you actually build your own NAS, if you actually get a motherboard and a CPU that's separate, well, if you want more, compute power, replace the CPU. If you need more memory, add some more memory. And it allows you to actually start small, really, and expand out. And I think that's going to become a bit more important, because we're now into like a NAS solution that's going to be supporting virtual machines, for example. You need, much more compute power. You need much more memory to be able to do that sort of thing. And yet you're going to be limited with a NAS that you buy that's pre-built. So I'd say that's really my final decision. That's what finally swayed me and pushed me over the line, really. The security and the stability are just too important, but that extra benefit and the longevity I'll get from being able to expand this NAS, I think that's just the final tipping point for me as to why I finally decided it's about time I actually built my own NAS. Now you might be wondering then, well, what actual kit did you actually buy to build this NAS? Well, this is it. All of the kit that I used, I've laid out on the table here. Just to give you some idea of what it is that I purchased. But I'll go over each of the different parts and try to explain why it is that I went for those specific pieces, basically. But I must admit, I really struggled to get any kit. At the time of this recording, we're still having problems with chip shortages. Not only was I finding certain parts just ridiculously expensive, but quite a lot of the sort of things I would have been interested in were just out of stock. I mean, for a typical computer, in the past, I've been building PCs for a long time. Usually what I would do is just, I'll buy, the fastest processor and the fastest GPU that I can, justify in my budget, and then everything else just fits together around that. But in the case of this NAS, well, we're into needing a lot of storage capacity for one thing. It's going to be running 24/7, and at this time of very high energy costs, I'm more, inclined to try and keep the actual power utilization down as best I can. So it's an interesting mix, I must admit, but I'll go over the different parts and explain how I arrived at these decisions and why I picked these specific pieces to make this NAS. Now, when it comes to building my own PCs, there is one tool that I like to use, which is this website called PC Builder. Now, if you haven't already heard about it, it's a completely free website that you can use, and I'll leave actual links in the description. But what it allows me to do is essentially pick out the various components that will make up this PC, and it'll come back with, compatibility issues, for example. So that's a lot better than actually just purchasing the kit and finding that out afterwards. Another good thing is it filters the actual options out. So here we've already got a motherboard picked out. If I were to click on CPU, it's going to basically filter out my choices. So I can't pick an AMD processor for this motherboard. So not surprisingly, it's grayed out. And the good thing is, based on this list that I've got, I can start filtering things out even further. Maybe there's a certain family of processor I'm looking for. Maybe I need one that's got an integrated graphics card and so on. Very, very flexible, I must admit. I do find that useful. Now, by default, what it shows you over on the right is basically the cheapest vendor that you can actually purchase that item from, assuming it's available. But you can also just click on the actual item itself, and aside from giving you more details about that actual product, it actually gives you a list of the different places that you can actually buy it from, the different prices you'll get charged. That's good. If you go down further, you might find where other actual people who've been using this site will actually, tell you about that specific part that, if they've actually used it in their build. So that's quite useful to find out as well. So it's a really good place where it kind of consolidates everything. You can just basically pick out your parts and find out, oh, I can't get that specific part. Well, what's my alternatives, for example? And in this particular time when we've got chip shortages and so on, I found it to be extremely useful for being able to do that. So if you haven't already checked this website out, I do really recommend you do. Now, usually when I build a new PC, I actually pick out the CPU first, because I'm looking for the fastest CPU within my budget range. But because I'm building a NAS, I have to be able to support an actual lot of hard drives, in which case I'm starting with a motherboard first, because ideally what I want is a motherboard that's got all of those SATA ports built in. So here we are on PC Part Picker, and you can see I've put in a series of different filter options to try and find out what type of motherboard will meet my requirements. So I'm going with a minimum of 4 memory slots. That gives me more expansion for memory. So I can start with 2, then add 2 and so on. Because I need a lot of hard drives, I felt 8 was enough for my requirements, so I've set a minimum of 8. Ideally, I'm looking for support for NVMe slots here as well, so I've picked out a minimum of 2 on the board. That way I'll be able to get faster throughput for certain data, for example, or be able to use those for other purposes. I want to keep the costs down, I want to keep the power down, in which case ideally I want a CPU with a built-in GPU. That means I need a motherboard that'll be able to support that. So that's why I've gone with this option here, where it says onboard video depends on the CPU. So the motherboard actually has the actual video ports built in. So as long as the CPU's got a built-in GPU, you don't have to buy an additional graphics card and you don't have to power it either. And then our final choice over here is to do with ECC memory, because I've gone with this because it makes a lot of sense for a NAS, in the sense that I'm going to be running TrueNAS. I'm going to be using ZFS, and data integrity is very important to us. So that's why I went with that option to say I want the motherboard and ultimately the CPU to be able to support ECC RAM as well. But as you can see, it doesn't really come back with a lot of options. I mean, we've got a choice of this motherboard or these 3. The thing that stands out to me here is the fact that these 3 are all ATX motherboards. Now, the bigger the motherboard, the more power it uses. Ideally, I would have loved to have found like a mini ITX motherboard, but I really struggled. So in this particular case, because of these requirements that I've put in, this one really is the only option I can go with. It's a micro ATX motherboard. It can support up to 128 gig of RAM, which, you know, is great considering all these other options. This is a pretty good board as far as I can see. I mean, we've got server or workstation motherboards, which might have made more sense, but I don't quite like this one, I must admit. When you click on that, you get all the, you know, the options for the costs, the shipping, and then from there you can pick out, you know, if somebody's actually got it available for purchase, for instance, or you can always buy these things second hand. Gives us a lot of details down the left of what it supports and so on. So yeah, in the end, I ended up settling on this particular motherboard. So I'll just click on Add. So that's our motherboard picked out. Now the next thing to do was to pick out the processor. Now, fortunately on this PC part picker, when you go to pick a processor, it'll actually filter out the ones based on whatever, you know, motherboard you've picked. It'll only give you a choice of ones that are compatible. Now, I do have extra requirements. So for instance, I want ECC RAM support. So there's a filter there. I'm also trying to keep the actual power usage down, so I set a maximum of 45 watts, and this is the result. And as you can see, there wasn't really a great deal of choice here, basically because of those extra requirements that I'm placing here, also because of the chipset and so on. But sifting through these, I'm not overly fond on these 3, even though that one's the only one currently available. It's the only one with a price. It's the only one I can purchase now, at least new. It's still a case of, well, 2 cores, I'd rather have 4. So it came to a choice of really one of these 3. So I thought I would go with that one, the i3-9100T. Now, that one wasn't actually available in stock. I went over to Intel's website. I'll include a link for it. But when you filter out things on here, for instance, they do mention the the i3-9100T here. It was released in Q2 2019. So it is like a processor you can still actually buy. But if I click on the actual processor itself, you can see there is one particular retail shopper, at least in the UK, that was offering that, but it's out of stock. So what I actually ended up doing was I actually purchased this as a refurbished CPU over on eBay. The idea is that it's come out of a used equipment basically. But what I did is I made a bit of a check, and this particular seller was selling the actual processor with a warranty of 3 months, so that if the actual processor didn't work, I could return it within 3 months. So that was quite useful. It's not as good as, at least here in the UK, like if you buy it new, you get a 1-year retail warranty. So it's better than nothing. And as I say, I wasn't overly fond of just ending up with an Intel Celeron. I'd rather get something at least with that, 4 cores. So that's what I went with. So we'll add that to our list. Now, I'm not going to go through the rest of the components with that much detail, but hopefully you've got an idea of how useful this site can be for picking out, the various parts that you need. So the other things that I've got are what it's referring to here as a passive fanless CPU core. And this particular one, it actually got a pretty good review, in which case that's why I opted for this one. And it's basically just a heatsink. We don't actually have an actual CPU that's going to generate a lot of heat. It doesn't need that much cooling, so we can get away with just a heatsink. The motherboard supports dual channel memory. That's why I've got 2 sticks of memory. So in this case, we're starting off with 16 gig in total, but it's better to have 2 8s rather than a single 16, because we can put those 2 into the proper channels and we'll get better throughput than we would if it was 16 gig. The only thing to bear in mind is we're not looking at blazingly fast requirements here. It's not like PCs or anything like that. So it doesn't really matter a great deal, who the vendor is and that sort of thing. But one thing I will point out is you do want it to be ECC unbuffered. Now, what I actually did, to be honest, I couldn't find an actual a vendor that sold any of this type of memory, but I actually went onto Kingston's website, for example. That's really useful because if you give it the actual motherboard, it'll tell you what memory will actually support it. So that was an easy way for me to pick out my memory. When it comes to the storage, well, I need something to boot TrueNAS from. I'm not going to use a USB drive. And to be honest, this was pretty much the lowest level I could get for an SSD at the time. 250 gig is way more than you need for the operating system, but that's what I opted for. Normally I buy like Samsung Evo SSDs for high throughput, but again, you don't need anything like that, so I just went for this Crucial MX500. For the actual storage itself, I've opted for these 4 6TB drives. In total, the way I'm going to put these together, I'm going to get a complete set put together is going to get me 12 terabytes in total. So it gives me tolerance and redundancy to lose potentially 2 drives. 12 terabytes is way more than I need, but one of the things I was looking at was the actual speed of the drives. I've used Western Digital as well as Seagate over the years, but one thing that stands out to me is that because it's going to be a 10 gig network, it's better to have 7200 RPM drives. I could have gone up to like 8 terabytes, for example. I think that might have been a tolerance for like the Western Digital ones, but in this case I was able to get these 6 terabyte drives that'll do the 7200 that I'm looking for. They've got a slightly smaller cache than the 8 terabyte equivalents, but when you compare the costs, this seemed a better option for me. The one thing I'll point out is that these are the Iron Wolf Pro, so these are proper NAS drives that I'm using. I don't want to go down that path of picking out drives from external drives and using those. The reason being is I actually looked into shucking, and it was extremely expensive at the time of recording, or at least at the time I was looking for these drives. The actual external drives were more expensive than the internal drives, so go figure. Also, oddly enough, the Iron Wolf Pro here, the 6 terabyte Iron Wolf Pro, was cheaper than the Iron Wolf. So I'm not quite sure what's going on there, because these particular ones, they do have the data recovery with them, so it seemed a bit odd, but that's what I went for 4 of these Iron Wolf Pro 6 terabytes. In an ideal world, yeah, SSD drives, we're talking 10 gig networks, but the reality is spending that sort of money on SSD drives for me is just not practical. Most of my budget's going to get taken up by purchasing these sort of hard drives in the first place. The next biggest cost is the motherboard, and then we're into the actual case. But these things, the hard drives, is usually where most of your money goes. And 4 is enough for me, because I say it's enough for tolerance for losing 2. I can always expand and add more if I need to, but 12 terabytes, that's way more than I need, to be fair. But yeah, I was quite happy picking those. I think I was just looking in terms of maybe the timing to get the Pros versus the normal Iron Wolves. I want to be able to take advantage of some NVMe drives, and that motherboard actually has 2 slots. So I just went for these Patriot ones. Probably would have been better to go with something else, but given the price, given the reviews, they're pretty good for what I need, to be honest. I think the idea is just something where I can upload data quickly enough. I'm going to test out slogs for ZFS, for example, but for the price they're asking for, that seemed pretty good for me, so that's why I went for the Patriots. Long term, I might think of something else, but I'm trying to keep the budget costs down, and a lot of it, as I say, is taken up by those NAS drives. When it came to the case, well, I think this was kind of like the Goldilocks effect. It's a Fractal Design Node 804. So it's a micro ATX case. It's capable of mini ITX as well as micro ATX, and it's a micro ATX board we've got. Now, I want a case that's, fairly good to work in. I don't want something that's really, really cramped. And the sort of like reviews I was reading, its capabilities, it can support up to 8 drives in the cage. It's got 2 cages that can support 4 drives. You can put 2 SSD drives in the front panel. You can put another 2 SSD drives in the lower chassis itself, or even mechanical drives if you like. So it's got a lot of capacity for drives. It's got a lot of capacity for fans. It comes with 3 system fans to begin with, 2 at the rear and 1 at the front, but you can put another 1 at the front. You can put more in the top. I think there's like a total of 4 you can put in the front. So it's got a lot of, expansion capabilities, I think, and it's a pretty good size, and based on what I'd seen on YouTube, I did quite like that. Now, I think I've been a bit unlucky in terms of probably the timing, because at the time this thing was just not available. I couldn't actually buy it. Interestingly enough, when I went and had a look on Amazon, although it wasn't in stock, the vendor was actually asking for £288 compared to now it's 167. So yeah, go figure. But because I couldn't buy it anyway, I actually ended up buying it second hand. Somebody was selling it for half of that price on eBay. It's got some scratches, but no big deal. I'm not really bothered about that. It's going to be out of sight anyway. And I mean, I'm not going to be throwing anything else at it, like, RGB lighting or anything, because that's going to consume power. So it's not as if it's going to be on display. So the scratches it's got, yeah, it's not a big deal. It works great, just what I needed. So it is quite a good case. I've used Fractal Design in the past. I mean, I was looking at some other options that they provide, and that one, I think that just kind of like hit the sweet spot. So I do like that option. When it comes to the actual PSU, in the grand scheme of things, it's not that big of a problem. I mean, it's entirely up to you. It's a case of having a look at the sort of like the wattage that they're quoting, and getting a PSU that can cope with that and more. So in my case, I opted for something that was around about 500 watts. And I do like to have a modular power supply. And I've been using Be Quiet in the past. I've used other ones as well. At the moment, that seemed a pretty good option for its capabilities. Couldn't really justify a platinum or a titanium PSU. Didn't really want a bronze, so I opted for gold. So it was a pretty good choice, I think, for the actual for the cost basis, especially since it's a modular one. So that's what I've gone for with the actual power supply, because the actual case itself supports ATX PSU, so that's good. The only other thing really is the actual network card. Now, I want the flexibility of being able to support fiber or copper. So I opted for one of these, except it's actually the 1-port version. So the idea is, well, I don't need redundancy. I'm not going to have 2 10-gig switches, so there'll be no point having 2 ports. But I do want that flexibility of either fiber or copper. So something like this, it actually has what's called an SFP plus port, meaning you can put in a 10-gig port that's copper-based, an RJ45 port, or a 10-gig port that's fiber-based. Now, I'm not overly fond on copper, simply because of the actual heat generated. If you put an actual GBIC into there, an SFP GBIC into the actual port, one of these transceivers can actually get very, very hot. If you've got an actual switch which is fanless, for example, that can cause you problems. They will warn you, you can't put that many copper SFPs into the actual slots. It'll just overheat the actual switch. So I want that flexibility, because the way I'm leaning now is that I'll probably put fiber in the actual walls, floor to floor. I was originally going to go with copper cabling, but I think what I'm going to do now is I'm going to go with fiber through the walls if I can pull it off. That way I'll still be able to get my 10 gig. It'll use less power. It'll also generate less heat, in which case I've got to have an SFP plus port on these NICs. For where I'm talking about connectivity within the rack, I'll just get a direct DAC cable. So that's a cable that's got the actual transceivers built in, already wired up at each end. They're a lot cheaper. So the copper options are a lot cheaper. It's just that heat generation. You need more power to be able to push that energy through a copper wire than you do, for fiber. So it uses more power, generates more heat. So that's why I wanted that particular option. Now, at the moment, I'm just sticking to the system fans, and I was having a look at the Noctua ones. I've used Noctua fans in the past for building PCs because they do tend to be better for the actual noise reduction. So for now, I'm just going with a system fan. So there's 2 at the rear, 1 at the front, and I'm going to have a look over time, see what the thermals are like. I might think about replacing them with the Noctua ones. If I do, I'll end up getting a proper actual hub fan, a fan hub rather, that can support multiple fans. That would be a better strategy. So I haven't actually bought any of these yet. So the idea would be 2 140s at the rear, 2 120s at the front. It's a bit cramped. I can't realistically see me being able to put any fans in the roof of this case because there's not that much room between the drive cage and the actual top of the chassis, to be honest. But at the moment, we're going to have to just see how the thermals do, because the noise levels aren't that bad. I mean, I have actually already built this incidentally, but in terms of the noise levels, they're not too bad at the moment when it comes to those 3 system fans, and the thermals do seem okay, I should say. But I'll have to see longer term whether it's worthwhile replacing them, because I've only got these 4 mechanical hard drives. I don't have a GPU in here, for example, generating a lot of heat. It's just a low power CPU, so that doesn't generate a lot more heat either. So that's pretty much the sort of kit that I've picked out to get started. It's like a combination of, I need a motherboard that's got the capability to support a lot of drives. I need a CPU to keep the power usage down, and then the rest just basically follows. Well, the NAS has now been built, and I've been running tests that compare file transfers over 10 gig versus 1 gig. Now, when it comes to actually transferring data from one computer to another, the fastest rate that you're going to achieve is going to come down to whichever part in the path is the slowest. And on a 1 gig network, it's typically the 1 gig network itself, hence the reason for wanting to upgrade to 10 gig in the first place. But once you actually upgrade to 10 gig, well, then we're in a game of whack-a-mole basically, because there's all sorts of different places that can suddenly start popping up as a bottleneck to slow the actual file transfers down. What you have to do is identify where that bottleneck is, try and improve that as best you can, and then start looking for where the next bottleneck actually is. So these are the sort of challenges that I ran into whilst I was trying to improve the transfer rate over 10 gig. Now this computer that I've got here is a Windows 10 computer, and it's got the same Intel NIC that I'm using, the actual NAS. So they're both connected to the same switch, which means I should get 10 gig connectivity between this computer and the actual NAS. So the expectation straight away was I would get some, really good transfer rates when I copy a file from this computer across to the NAS. So here we are, where I've got an actual video file. It's just under 15 gig in size. So I'm going to copy that, and I'm going to copy it across to the NAS. So this is an actual SMB share on the NAS. Control V, and you can see we're getting a pretty good transfer rate, and then it suddenly tanks. It's running very, very slowly here. It's wow. I mean, that's not much faster than what I was getting at 1 gig. Now, what I found was that if I go into Task Manager, and this is a good place to start, the actual hard drive that I'm using, which is it's an actual mechanical hard drive, it's pretty much maxing out, and that's where my actual first bottleneck is. What I'm trying to do is transfer this file off the hard drive here across the network. Now, the network, it's a 10 gig network, but the actual hard drive, as you can see, it can't serve the data fast enough. So it's the reason why I'm not being able to get such better transfer rates than this. Now, that's not something I specifically noticed when I was using 1 gig transfers, when I had a 1 gig network, because the actual network was the bottleneck. This time round, the actual hard drive I'm using on the PC itself is the bottleneck. I'll have the same sort of problem if I actually try to download data from the NAS to the actual computer, because this hard drive, well, it's not really cut out for sort of like high transfer rates. So what we're going to do is just going to wait for this to time out, and then what we're going to do is swap over to an SSD instead. Now, they are going to have much faster transfer rates than a mechanical drive. The reason I've got an actual mechanical drive is just because I've got a need for large storage on this computer. But I'm going to go over to my D drive. We're going to grab the actual file here. I'll do a copy and paste of that file. Say yes to replace it. And you can see the transfer rate, it's a bit more steadier. We're getting into the high 600s, which is a bit better. If we have a look in the actual task manager, you can see that a hard drive isn't maxing out. Interestingly enough, the actual network card itself isn't. It's getting to about roughly 5 gig per second as far as it's concerned. But it's going pretty fast, at least compared to what a 1 gig network would be capable of. But that's probably one of the first areas you want to look is have a look at Task Manager and try and find out if something on your computer is actually maxing out, because that could be the reason why your transfer rate isn't as fast as you'd expect it to be. Now, if you're not seeing any obvious bottlenecks on the computer that you're trying to send your data from, then the next thing to check is the actual network to try and see what sort of throughput we can get in just a basic raw data transfer session. A useful tool for that is Iperf. Now, TrueNAS actually has that built in, but we need to download this to our actual computer. Now, I've already done that. So if I go into the command prompt, if we look at our folder here, there's an executable file for Iperf version 3, and there's a DLL, a dynamic link library file that goes with it. But what I can do is just run that command from this computer, and then I can test out my throughput using Iperf. But before I do that, I need to actually set up TrueNAS to listen. So if we go over to TrueNAS, now this is TrueNAS Scale. I've gone into this actual shell, so I've gone to System Settings and then to Shell. And then what I need to do on this version is to run Iperf 3 and then use the -S option to set it up as a server. We go back to our PC, and then what I'm going to do is then I'm going to run this as the client. So Iperf 3 -C, we need to tell it what we're connecting to. And then off it goes and it starts up all those multiple sessions. So we're trying to send quite a lot of data at the same time, because we're trying to push the limits. We're trying to see how much data can we actually send through this NIC if we send a lot of files, because 10 gig, that's really when it's at its best, is when you're sending a lot of files. That's what it's intended for, not really just one file and where you're just sending a file and you're trying to achieve 10 gig with that. It's better suited to multiple files. In this case anyway, the actual little trial what we were running is finished, and it's getting close to about 9.9 gigabits per second. So that's pretty good. I mean, when you think it's a 10 gig link. So yeah, I mean, that's pretty good. I mean, I'm comfortable with that. But I must admit, I wasn't getting this sort of throughput originally. If we go back to our Windows computer here, what I was actually finding was when I originally ran Iperf on this computer, Windows was actually reporting less than 5 gigabits per second. So I checked the switch, and both links were reporting 10 gig per second, so obviously no issues there. We've got 10 gig connectivity from the PC to the switch, 10 gig connectivity from the NAS to the switch, so it couldn't be that. So what I then did is I actually rebooted the computer, booted up with a live version of Linux, Pop! OS as it turned out. I ran that and I was getting around about 7 gig per second throughput. So therein, lies in one interesting feature, shall we say. There's that it's been known for a long time that Linux is a lot better than Windows anyway, especially when you're talking about transfer rates. But even still, I wasn't getting close to that 10 gig limit. So I did a bit of digging just to check. And this particular computer that I've got set up, it's using a relatively old motherboard. It uses PCIe 3. But if I go over to the actual manual, what I did is I plugged the 10 gig card into this slot here, so it's a PCIe 16 slot. Now, what should be happening is, at least my expectation goes, was this particular slot should be suitable for like a 10 gig network card. But for whatever reason, I just wasn't getting a good throughput. I mean, if you check the manual, these two cards here, they do share some lanes in the sense that this is going to have 16 lanes. This is where you put your video card. If you were to put a card into slot 2, it drops it down to 8, so the two of them are actually sharing the lanes. This one's separate. So I did a bit more digging. I went over to a bit more detail here, and you can see this particular card, it shares the lanes that it's got with two of the SATA ports, ports 5 and 6. By default, it's running in ×2 mode. Now that should still be enough for a 10 gig card. Now, because I'm not using those two slots, what I did is I swapped it over and I set it up to use all 4 lanes. So that's more than enough for a 10 gig NIC. Even 2 lanes is enough, quite frankly. But all of a sudden when I did that, that's when I started getting these much higher throughputs, much more closer to 10 gig even on a Windows computer. So I must admit that wasn't something I actually expected. It's something to bear in mind is that PCIe 16 slot just means that's the size. 16 is the actual size. What really is important is the number of lanes that you've got. Now we're now into PCIe 4, which is much faster. I can get more out of 1 lane in PCIe 4 than I can out of 2 in PCIe 3. But even still, I must admit that kind of threw me. I was expecting it would just work anyway. But that's just something to bear in mind is, yeah, but maybe it's just a feature within the motherboard or something. For whatever reason, even at ×2, I still wasn't getting that actual higher throughput that I was capable of when I swapped it over to 4 lanes. So yeah, do check the manual of your actual computer. Now another common area to find bottlenecks is actually on the NAS itself, more specifically the disks that you're using. Now I'm actually using Seagate's Ironwolf Pro disks for this. So these are NAS ready disks, but they're still mechanical disks. So it's not surprising that they're actually going to be my next bottleneck. Basically, I'm sending data over a 10 gig network and the NAS cannot write data to those disks faster than it's actually receiving them. Now what I can do is keep adding more and more disks and that'll speed things up. But in this case, I'm just sticking with 4. It's enough for me. I've got plenty of actual storage space and it's difficult to justify a higher throughput given the actual costs of these disks. But just to give you a sort of like an example of what it's like copying to a mechanical disk versus say like an NVMe, I've set up an actual data pool using one of these NVMe's. Now to be fair, this isn't the best sort of NVMe you can get. It's actually a pretty cheap one, so the right throughput rates are quite low compared to most others, but this is just going to give you some sort of comparison of what an SSD or NVMe transfer is going to be like in comparison to these mechanical NAS ready disks. So I'm going to copy that and then I'm going to paste it to this NAS share here. So you can see we're right up into the 700s where we're touching the 800s at some point. Now what I find is it tends to vary, but this is still a heck of a lot faster than what I was getting when I was writing to the actual SATA drives. And again, bear in mind, these aren't the best sort of NVMe drives you're going to see on the market anyway. I could do a lot better with much better drives if I was willing to spend the extra money on them. But the reality is, when you look at the cost of SSD drives, the longevity, in other words, how many writes that they can handle compared to these NAS ready drives, well, quite frankly, it was an easy decision, really. The actual transfer rate improvement that I'm going to get really, for me, isn't enough to justify purchasing SSDs instead of mechanical drives. For a business, it would make a lot more sense. They can afford that sort of thing. But in a sort of like a home, no, I'm just going to stick with the actual drives. Now, what I could do is I could improve it to some extent by adding more actual NAS ready drives. That means there's actually more disks to write to, and that would actually increase the performance a bit. But at the moment I've got much more sort of like data storage than I really need anyway, so it's going to be difficult to even justify that. And at the moment it's very, very expensive to actually buy IT equipment anyway. So basically that's really my main bottleneck, so I'm pretty much stuck with that for now. Well, once you've identified and removed the more obvious bottlenecks, the next thing to do is to move on to fine-tuning. So at this stage, we're just looking to try and eke out whatever possible extra performance that we actually can across this 10 gig network. Now, if you're going to be transferring large data files across the network, then one way you can actually improve the performance a bit is to introduce jumbo frames. So here on this computer that I've got, we've got the Intel software that goes with this network card. If I go down to where it says Jumbo Packet, yeah, you can see by default it's set to disabled. But what I want to do is actually change this to, in this particular case, 9014. That's what's considered to be a jumbo packet. Now, I've already got that configured, so I don't need to actually apply the changes. And bear in mind, if when you click on that apply button, if this is your main network card, you'll see a network drop. But what it means basically is that when it actually starts to break down the actual data file into what are called frames. Those frames are going to be much bigger, which means there's less of them need to be actually sent to get that bigger file across the network. So the transfer rate does go a bit faster. Now, we need to do the actual same for TrueNAS in this case. So if I go over to TrueNAS, if we go to where we've got network here for TrueNAS Scale, I'll have to pick out the actual interface that I want this for. So I'll click on the interface. It takes us into the settings. And then down here, I've got an option for the MTU. Now, the reason I went to the PC first is that's restricting me. It's only giving me certain settings, whereas TrueNAS here, it actually gives me a choice. I can literally type in any number that I like, but it helps to actually set this MTU size here so that they both are in agreement. So I've set that one specifically to 9014. Bear in mind the actual switches that you're using have to support jumbo frames as well. So you'd have to have a look on the actual switch configuration for something to actually set that jumbo frame option. Now in my case, the switch I'm using, it actually sets jumbo frames up by default, and there isn't even an option to configure them, so I can't show you how to do that for that particular switch. But what it means is that when these two computers are talking over this 10 gig network, they'll actually be using jumbo frames, so the transfer is going to be quicker. The only thing to bear in mind is that as soon as you introduce jumbo frames like this, you should really be doing it on every other computer you're using. Now, I've been doing it on 1 gig networks anyway, just because the fact I do send large files and I want to take advantage of those jumbo frames anyway. So all of my computers do use a jumbo frame size of 9014, but that's something else to bear in mind. It's not just specifically that you just configure, oh, I'm going to configure on the PC and the NAS and that's it. Make sure to configure it on all of the other computers that you've got. Otherwise, you can sometimes have a bit of a performance hit if they're not all in agreement. Now, when it comes to a PC like this, there is one more area where we can do a bit of extra fine tuning, and that is to change the buffers that we've got for our network card. So in this particular software that I've got, we've got settings for the received buffers. So this is for traffic that we're receiving from the actual network. And then on the flip side, we've got our transmit buffer, which is for traffic we're sending to the network. So there might be a bottleneck, somewhere in the actual computer. It helps to be able to actually buffer this actual traffic as it's being received or sent. So when I was having a bit of a look in terms of what to do for these 10 gig cards, one of the suggestions was to set the receive buffers to 4 meg. By default, it's only 512 kilobytes. So we've got it set to 4 meg here. And then when it comes to the actual transmit buffers, that goes all the way up to 16 meg. So these are actually maxed out. I can't get them higher than this. I can't actually type them in with this software. All I can do is go up and down with the actual arrows. But ultimately, the idea is we're providing a bit of a buffer just to give us that bit extra time to deal with the actual data. Bear in mind, it does introduce a bit of latency, but in my case, I'm more interested in actual sending, very large files anyway. So increasing these buffers does help a bit. Now, the next area to be looking is the NAS itself. And one change we can make there is to the record sizes that we use. So when we create data sets like these ones I've got here, what they do is they inherit whatever the actual record size is for the pool that you created. And by default, that is 128K. So I've got a data set here that's set to 128K, but I've deliberately created another one that's actually got a record size of 1 megabyte. So I'll go into the options for that data set. Scroll down to advanced options. You can see I've actually changed the record size to 1 meg. Now the reason for that is that if you've got very large files, like media files, like I'm mainly using here for transferring video files that are very, very large, 14 gig plus, they actually benefit from having a 1 meg record size. So the idea is to create different data sets to store different types of data. Now you're going to have a look and see what type of record size you need, but from what I've been looking into, the idea is I'm just checking is that if you're dealing with big media files, 1 meg is the sort of setting to use. For virtual machines like Proxmox, for example, files that are using QCOW, for instance, then for those you're looking at 64 kilobytes. Databases actually benefit from much lower actual record sizes. I was looking at one, for instance, that's referencing a record size of 16 kilobytes. So if you don't get it quite right, it can actually adversely impact the performance. So typically you'll go with 128K by default, but if there's a certain type of data you've got that might actually benefit, then do change the record size. So here we've got two data sets, and I've got two different actual shares set up for them. So up to now, what we've actually been doing is we've just been transferring to the 1 meg actual record set. So that's what this one is here. So I'll just step back a bit. I'll go to the share that's set to 128. I'll just delete that file. I'll grab that file, copy it across, and we'll just look at a comparison of that one. So it starts off pretty good, which is an expectation really, but then it's going to slowly start to slow down, get slower and slower and slower, because you get this burst where we've got a lot of data coming across. That's getting buffered, it's going into RAM, but TrueNAS has to actually then start writing that to the actual disks, and it's just getting slower and slower, as you can see, and that's when it's 128K. It also is the same when you're actually reading from the actual disks. If you're pulling data and it's got a bigger record size, the performance will be a bit better. But you can see it's going down to a bit of a crawl there. It was getting as low as 200 something. And you can see a bit of like a seesaw effect. That's the nature of TCP. It actually balances itself. If things start to get too fast, because it tries to push as fast as it can, and if it's starting to get too fast, it starts to back off, and then it slows down, and then it starts to speed back up again. So you get this bit of a seesaw effect. But if we go back to the 1 meg record size, this is just a bit better. And as I say, this is mainly because I'm transferring these much bigger files, so they're better suited to bigger record sizes anyway. So that's going, again, we're getting this slow down again, but it makes I'd say a slight change. You're not going to notice anything, miraculous, a massive change. In this case, we're just transferring one file. Overall, you'll get a much better performance by having that bigger record set. But it's just another area to think about if you want to try and fine-tune things and get that bit of extra performance out of the actual data transfers. One thing I should actually point out is that when you change the record size on a data set, it only applies to new data. So if you create a data set and you leave it at the default setting of 128K, for example, then upload some data. If you then go and change the record size to 1 meg, for example, that data that you've already got stored on the drive isn't going to change. It's still, set up for its original 128K record size. When you upload more data, that's then going to start taking advantage of that change to the record size. So that's just something to bear in mind. Now, if you're using TrueNAS Core, then you'll find plenty of advice and guidance on how to actually fine-tune the actual NAS itself. But that's basically just been proven quite a struggle for me while I'm doing this for this TrueNAS Scale. And it makes sense, I suppose, because TrueNAS Scale is based on Debian Linux, and it's only been out for a very short time. FreeNAS, which then became TrueNAS and is based on FreeBSD, has been out for a long, long time. So there's been plenty of opportunities and a lot of testing done to actually try and fine-tune things a bit more. Now, if I go to System Settings and then go to Advanced, unlike TrueNAS Core, there's no option in here for the actual auto-tune, nothing to give you even any rough guidelines as to what it thinks you should be using. So the furthest I've actually gone, and first I'm willing to go, is just to tweak the actual memory buffers. So we've got the receive memory buffer and the write memory buffer specifically for TCP, which is the main protocol that gets used for the file transfers. So I've just basically maxed those out to 16 meg, and they're going by the sort of settings I've seen coming from TrueNAS Core itself, for example, and various suggestions I was looking into for Debian systems. But the problem I'm finding is that what might necessarily work for one person's Linux and their particular brand of software may not necessarily work here. So I'd rather just hold off for now until TrueNAS has been out, or TrueNAS Scale I should say, has been out long enough, so that I can get a more informed opinion as to what's best to do with this, because you start tweaking with these settings and you can mess things up. But just to give you some example, what I've got, as I say, is just these two settings. If I click on that, we've got that particular variable that's been set up, and there it's settings that we've got. So it's slightly different to how FreeBSD gets done. If I go into the actual shell, just type in sysctl, if I could type -A, I'll just do a search for like TCP settings, for example. There's various information it's going to come back and tell me that it's been set up, for example. And I know, for example, when I scroll through this, I found there was like the congestion algorithm was set to, it offers both Reno and Cubic. FreeBSD, for example, uses Reno, but this one's actually using Cubic here by default. I'll just try and maximize this if I can to make it a bit easier to read. You can see by default Linux is using the Cubic algorithm, which is what Windows is using as well. So I don't necessarily need to change the congestion algorithm on TrueNAS Scale, whereas you did with TrueNAS Core. But there's all sorts of settings that we've got in here, and you can find out what the defaults are. But the trick is trying to figure out, well, what do I actually want to change them to? What do I want to enable and disable? I mean, I've tried disabling certain types of acknowledgements, for example, and it didn't really make any difference for me, at least, even though there were recommendations for 10 gig networks. I didn't see any particular bonus, any particular improvements when I was transferring files across. So like I say, I think that's probably about as far as I'm willing to go for now, at least in terms of trying to tune the kernel. Now, although I've increased the TCP buffers on TrueNAS, the uploads that I'm seeing from the PC to TrueNAS are not as smooth as I'd like to see them. In other words, if I actually have a look at the switch, and more specifically the actual interface statistics, what I'm seeing is for this particular 10 gig port, the actual RX pause column is actually increasing. And what that basically means is that the rate of transfer from the PC to TrueNAS is too quick. And TrueNAS is actually sending instructions back to the PC using flow control to tell it to slow down and pause the actual data transfers because they're just too quick to cope. Now, one thing I can actually introduce to improve that is to increase the ring buffers on the actual network card itself. So here in the shell, I'm just going to go back through the history of this command because I keep forgetting what the actual interface name is. But we're in the command ethtool-g and then the name of the interface. So if I hit return, it comes back and it tells me what the maximums are, but it's actually got these settings for the receive buffer and the transmit buffer set to 512K. Now, I've had a look around, and on a 10 gig network interface, the suggestions really is you're better off with 4 meg. Now, if I actually look at the 1 gig interface, these are 256, so these must be some conservative estimates that that comes with the card. But I'd really like to have these bigger buffers, because that would buy TrueNAS more time to actually get the data off the actual network card and actually do something with it before the next set of data actually arrives. So to do that, I'm just going to bring that command back up again and change that to a capital G because we want to make some changes. So we set the receive buffer to be 4 meg. May as well increase the transmit buffer. I'll hit return and these changes get applied on the fly. Because if I run that command again, you can see these are new settings of 4 meg. The only problem I'm finding is, although if I go back to the switch and have a look at the interface statistics, the RX pauses now actually stop. So we'll be getting a much smoother rate of data transfer. It's not that particularly noticeable, but if you've got like a lot of data going around, a lot of transfers backwards and forwards from different computers, that should help a lot. But the problem I've got is we're using this ethtool command. TrueNAS Core, which uses FreeBSD, actually has some system settings that you can make these sort of changes permanent. In a Linux environment like this is the recommended way of doing it, or the suggested way of doing it, I should say. But running this ethtool command, it means that it doesn't survive a reboot. And what will actually happen is TrueNAS, if for whatever reason it does get rebooted, those settings are going to revert back to the original 512K values. The suggested way of actually dealing with that is to actually create a script file and have that script file load when the computer boots up. But the trouble is we're dealing with a TrueNAS system and a Linux system, and to be honest, I don't honestly know if you get like an upgrade at some point where that all gets lost and I'll be none the wiser. It's not as though I'm going to keep coming back to this and checking, or is my script there, is it still running, are the buffer values still actually set the way I want them to. I'd rather see a better way of dealing it within TrueNAS itself, for example, or even Linux, I suppose, for that matter. So for now, although I've got them set, it's just going to be a case they're going to get lost anyway, so I may as well just leave them at the default settings for now. But it is something to bear in mind. I mean, it's not that major a performance, but again, we're into these realms of just making some fine-tuning changes, but just something to think about. Now, up to now, we've only really been looking at the upload rates, but what are the actual download rates like in comparison? So we're going to start off with what I would consider to be the actual slowest share that I've got. And that's where we've got 4 mechanical drives, and they've been set up in a pool. And I've created a data set on there with a default record size of 128K. So I'm going to copy that file. I'm just making sure that I'm on the actual SSD drive, because the actual mechanical drive in here will go really, really slowly otherwise. Even if I do an internal copy from that actual SSD drive to the mechanical drive, it's barely getting over the rate of a 1 gig network. It's that slow. So making sure that we're on the SSD drive, we'll copy that. We'll see what sort of transfer rate we get here. So, I mean, that's not too bad. I mean, we're getting into the territories of over like 4 gig per second. I've seen it kind of like spike a bit at 4.5. It's not unusual to see that spike at the beginning because you're tending to see data getting buffered first, and then it slows down to, you know, like the more realistic sort of levels that it can sustain. Well, that's not too bad, I must admit, given what we're pulling through. But bear in mind, this is a Windows machine. You'll get a better rate out of a Linux machine anyway. But that's pretty good, I feel. So if we then go back to where we've got a 1 meg record size, so this is the same set of disks basically. So these are 4 Ironwolf Pro disks that I've got. So I'm going to copy that file. And the only difference is the fact that we're using a 1 meg record size versus a 128K size. So we'll copy that down, see what that does. So this one I find is slightly faster. So this is more likely to touch about 5 gig per second on the download rate. So it does go that bit quicker. So it does pay to actually make sure that you're setting these record sizes up for your actual data sets and ultimately the shares that go with them to match the kind of data that you've actually got. Because in this particular case, I've got large files, so they do benefit from that bigger record size. So finally, what we're going to do is we're just going to delete that. We'll go to our NVMe. Now, bear in mind, this is not a really good NVMe. It's not a fair comparison. But the idea is I'm going to copy from what is just a single NVMe drive down to this PC here. So it's got a 1 meg record size, so I'll copy that and then we'll paste that. Now, what I can tell you now is the computer's stalling. I can feel it. It's literally stuttering, essentially. You can see how it's taking ages. But if you notice there, the actual speed is 1 point something gigabytes per second. Not megabytes, it's gigabytes per second. I mean, a 10 gig link, you're looking at about 1.25 potentially. So that was blisteringly fast in comparison. It just literally couldn't cope. One thing I can tell you is that if I were to look at the actual switch statistics, there'll be a lot of pauses on this particular computer's interface port. If you compare this PC to, say, the TrueNAS server that I've got, the buffers on that one are set up so that it's got a 16 meg actual buffer for its receiving. This one's got a 4 meg buffer. So straight away we've got buffer problems, but it's also the operating system will add a bottleneck in there. There's various issues here where the file's actually getting sent at a really, really fast rate, as fast as you can possibly expect on a 10 gig network. It just can't cope with it. The PC, I should say, can't cope with it enough. It's just too fast for it. Now, if I were to use a Linux machine in comparison, it'll probably be a bit better, but I mean, realistically, it's still blisteringly fast. I mean, that was under a minute to transfer that file. It was very, very fast. And it was just, I always just find it amusing when I see it doing that stuttering because it's just too fast to cope. And that's just because I'm copying from an NVMe disk as opposed to mechanical disks. But again, the reality is when you compare the time it took me to copy from, say, those mechanical drives versus the NVMe, it would be very difficult for someone like me to justify spending all that amount of money on SSD drives, for example, compared to those mechanical drives, because they get very, very expensive, especially when you want more data storage capacity. So it's a case of it's not really financially practical for someone like myself. For business, makes a lot of sense. For me, no. So I'll be sticking with my mechanical drives. Now, TrueNAS uses a file system called ZFS. If you've heard of ZFS, you might have heard of a ZIL, but you've probably heard of a SLOG and how that can improve your data transfer speeds. But to be honest, do you actually need a SLOG? Well, to answer that, the first thing we need to do is understand what an actual ZIL is. And I do find this website here helps to provide a better understanding. So if we look at this diagram, what we've got is data is going to come into our NAS. Now, it makes no difference whether we're going to have asynchronous writes or synchronous writes, that data is going to be put into RAM. Then from RAM, it's going to be written to disk in a nice orderly fashion. So that gives us a bit of a buffer basically for our writes. It speeds up the write process essentially. Now down here we've got what's called a ZIL area. So this is our ZFS intent log. But you'll notice it's only actually getting used by synchronous writes. Async writes don't touch it at all, only the sync writes. Now the reason for that is just to guard against a failure of the data in the RAM. So let's say, for example, the actual NAS were to fall over. Let's say you get a power outage. When it comes back up again, any data that was in the RAM at the time will be lost. So what we're doing is we're copying our data to RAM, but we're also sending another copy to the ZIL. So if we go a bit further down, what you'll see is that once the computer comes back up, we can read that same data that was in the RAM from our ZIL, put it back into the RAM, and then basically pick up from where we left off. So that's the purpose of the ZIL really. The idea is that we just want to guard against loss of the data in the actual RAM due to, for example, a power loss. But it's only used when you've got synchronous writes. If you're using asynchronous writes, there's no relevance to it whatsoever. And the key thing to point out here is that if you're using SMB or you're using Samba, for example, it uses async writes. If you're using iSCSI, it uses async writes. In which case, you only need to be interested in this sort of stuff if you're using a protocol like NFS, because by default, that's what's using sync writes. So the next thing to think about is, well, that's the actual ZIL explained, but what's the actual slog? And do I even need a slog? So what is a slog, and do you even need one? Well, if you look at this diagram here, we've still got our async writes and sync writes going to RAM, but now the actual sync writes are going to a slog VDEV instead of our ZIL area on the disks. So as far as SMB, Samba, and iSCSI are concerned, nothing's changed. In which case, you're not going to use a ZIL, you're not going to use a slog. If you attach a slog to your pool and you're not using NFS, for example, you're not going to achieve anything. You're not going to improve your write speeds, for example, because you don't even use that device. But if you're using NFS, essentially what we're doing here is we're replacing what was a ZIL with a slog. And the idea is to basically just alleviate pressure off the actual disks, because if we go back to the original diagram that we've got here, our writes are being sent to the ZIL. So we're writing from RAM into the actual disks. We're sending what is dirty data and putting it into a nice orderly fashion to create our records on the actual disks. And then we're keeping a copy of that same dirty data in the ZIL. If we come back down to here, we've just basically replaced the ZIL with a slog. So it's still the same dirty data. But what we've done is just taken pressure off the actual main disks themselves, where we store our final data, by writing that information into a completely separate device. Now, if you talk about business requirements, you're more into things like the Intel Optane, for example. The idea is you want something that can do very, very high throughput for writes. You still need to be able to protect against failure of the actual computer in case of power loss, for example. So that's something to bear in mind. But just out of curiosity, because I've seen on forums where some people say the slog, oh, it's a disk cache, it'll improve your write speeds. Some saying, no, it's not. That's not its purpose. It's not going to improve your write speeds. Now, granted, it's certainly not going to make any difference if you're using, SMB, Samba, or iSCSI. But what happens, just out of curiosity, if we create an actual slog using an NVMe and use that, attach that to our pool, is that going to actually speed up actual data transfers for synchronous transfers? Now what I've got here for my main pool is actually 4 mechanical drives. The way they're set up is actually they're mirrored VDEVs. So if I go to status, you can see I've got 2 drives in this mirror, 2 drives in this mirror. So these are 2 VDEVs and they make my pool. So because I've only got 4 drives, I felt this was a better choice over, say, RAID Z2, for instance. The reason being is that, well, for one thing, I'll get better performance slightly, but also it's a case of if one of these drives were to fail, then there's going to be less pressure to rebuild the actual system when I replace that broken drive. If I use RAID Z2, on the other hand, chances are that rebuild could break a second drive anyway. I'm carrying the risk if I lose, say, these 2 disks, for example, at the same time, then that's it, the whole pool's gone and I'm relying on what I've got in backup. But it's a bit of a trade-off, I feel, that I'm quite happy to accept. So if we go back to our storage, what I'm actually going to do is I'm not going to set up an NFS transfer here. I'm actually going to deliberately cripple this SMB. So if we go into our options here for the data set, actually I don't want 128, I want the 1 meg record pool record size. So I'll select that, I'll select edit options. So the sync at the minute is set to standard. Now I'm going to force it to always be on. We'll go down there, we'll click on save. So now I'm actually running SMB, but I'm going to be running it effectively as synchronous. So we go back to my computer, and what we're going to do is I've actually deleted the file. If I take a copy of that file, copy that and paste that, see what the transfer rate's like. Yeah, that's slow. I mean, that's slower than the actual 1 gig network was using SMB. So it just gives you some sort of idea of the penalty that you're facing when it comes to performance. So that's something to bear in mind. Now NFS would probably do a bit better, but to be fair, Windows isn't that good with NFS anyway. Usually if you're using NFS, you'd be using it on a Linux system, but that's a sort of like ballpark figure we're looking at, about 34 getting on about 35 megabytes per second. So yeah, this is going to take a while. So what we're going to do is let this finish, and then we'll pick up from there. Well, as we saw, that transfer was brutally slow. Now, like I said, I've seen on forums, reports by certain people saying, no, a slug, it's not there as intended as like a write cache. So it kind of, to me, I think the wording kind of skews the actual meaning and purpose of what the slug is, because what we're going to now do is attach an NVMe as a slug. I wouldn't recommend actually using one because they're not really designed for longevity in terms of the actual writes, for example. They're not really designed for this sort of purpose, but for the sake of testing, let's see what the differences are. So what we saw were pretty brutally slow transfers where we effectively crippled SMB and forced it into using synchronous writes. So what now we're going to actually do is to create a slug and attach it to this pool. So we'll go over to the option to add VDEVs here. And then what we're going to do is from the drop down menu, we're going to select the option log. We're going to pick our NVMe and we're going to copy that across. So this becomes part of this log VDEV. And as you can see, by default, it's set to stripe. Now we've got a warning down here saying you could lose, data basically if you end up with a power outage. So that's a fair comment. I'm going to force this option anyway. I'm going to confirm that, yes, because it's just for testing purposes. I mean, ideally what you want is 2 of these anyway. You'd want 2 of these devices because if one of these breaks, when you try to recover, what you'll find is you have problems not being able to get the pool back up and running because it needs a log device as part of the actual pool. Because that's once we attach this, it becomes part of the pool going forward. And if we're only using one device and it breaks, you can't mount your pool. You're going to have to detach it, then get your pool back up and running. So it's always better to actually have 2 devices and mirror them together. At the moment, I don't have enough of these devices spare to prove it, but it's a case of once you put these 2 in, from this drop-down option, select mirror instead of stripe, and then you won't get these sort of warnings. But either way, we want to just add this for the sake of testing. So we'll click on Add VDEVs. I'll confirm that we're going to erase the data already on that VDEV. So it's going to wipe the data on that. It's going to add it into the pool. And so now what we've got is a pool that's actually got, if we go to the status, it's made up of our 2 VDEVs plus our log. So let's see what we get when we do a transfer. So I'm going to go back to our PC. Just going to delete that. We'll do a copy and paste. Now, that to me seems, well, just a tad faster. I mean, instead of about 34, 40 megabytes per second, we're now up to the 400s, even touching at 500 plus at some point. So that slug has made a massive difference. Now, bear in mind, I'm just testing this on SMB, and I'm just crippling SMB with sync writes. it'll go better for NFS, because that's the whole purpose behind the slug in the first place, really. It's for synchronous writes, which is more in the realms of NFS. But you can see there, I think that slug makes a massive difference to your writes, simply because we're taking pressure off the actual original mechanical drive. So instead of writing the dirty data in a nice orderly fashion onto the disks, and at the same time writing dirty data to those same disks, now all we're doing is we're writing our orderly data to the actual mechanical disks. We're writing our dirty data for into the actual slug now. So it is genuinely taking the pressure off, and it's giving us much better throughputs here in this particular example. But it's something to bear in mind. I mean, if we come back to here, I'm using NVMEs. They're not really designed for this sort of purpose. They're not really intended for the longevity for a lot of writes. They'll only survive a certain number of writes before they fall over. If you're going to put one in, do it if you're using NFS and NFS only, effectively, because for most of the rest of the protocols, it's either usually going to be SMB, Samba, or iSCSI. If you're using any of those other three, forget it. There's no point. You're not going to achieve anything. If you're going to use NFS, then yes, I'd be more inclined to use SSDs than NVMEs, because I think they've got a better performance test when it comes to being able to survive more writes. I'll have to have a look into it a bit more. I mean, to be fair, I can't get any more anyway on this computer. The actual motherboard, I've maxed it out. I've put 2 NVMEs, but I've got enough slots spare to get 2 SSDs, and they don't need to even be high capacity SSDs. I mean, having a rummage around in the cupboards basically and see if I've got any spares lying around, quite frankly. Because this motherboard, it does have enough existing slots that I could actually add 2 SSDs, and the case itself would allow me to actually add those 2 SSDs into the actual front panel itself. I just have to get some more cables to do it, but that is definitely tempting, I'd say, for my hypervisors, for instance, that do use NFS. So bear that in mind. Hopefully that's proved some useful benefit to you in terms of, do I need a slug and is it of any use? Now, you may have noticed that throughout these videos we've been referring to TrueNAS Scale as opposed to TrueNAS Core. Now, this is a stable release. It's relatively new, and chances are you might have heard that the performance of TrueNAS Scale isn't as good as TrueNAS Core. I wanted to test that out for myself, so I did install TrueNAS Core, and then I wiped the system, installed this TrueNAS Scale, and sure enough, it isn't as fast, although to be honest, to me, it's not that noticeable. I mean, I'm not in a sort of like a business situation where there's hundreds of computers trying to upload and download files at the same time, so something like that's not going to be of such an impact to me. I think one of the deciding factors, though, because my plan now, I think going forward, is I'm just going to stick with this TrueNAS Scale, is that this system's based on Debian Linux, and most of the computers that I've got out there, they're either based on Debian, a distro of Debian, or a distro of a distro of Debian. So it's a case of, I feel a bit more comfortable having that versus FreeBSD. All of the operating systems are the same, so I do quite like that. I'm taking a bit of a hit there because FreeBSD is less of a target for hackers than, say, a Linux computer like this, for instance. But I'm just thinking of the longevity here, the direction that this is going in. Now, at the moment, I only need a NAS. I just need somewhere to store files, upload files, download files, working on files day to day, being able to back up to another local storage, being able to back up to the cloud. I can do that with just a NAS. I've got separate hypervisors to take care of my virtual machines. I don't really want to be running a virtual machine on this because this is just a single computer, so I do need a cluster of hypervisors no matter what happens here. But there's a lot of flexibility and potential for this, where this could potentially start replacing the hypervisors. I could end up with sticking with, say, Proxmox hypervisors that's got support for hyperconvergence, or you could be looking at a switch over to, say, like TrueNAS doing the same sort of thing. For now, it's just going to remain as a NAS because I've got a lot of flexibility with this particular computer because it's got the capacity for 128 gig of RAM. It's got 4 slots. It's got the potential to replace the actual processor as well. I went for this just for the sake of trying to keep the actual temperature down, trying to keep the power utilization down. But I can always replace this if I want to go get something better and start supporting virtualization, because I've only got 4 cores, 4 threads, so I don't have much flexibility at the moment. So I think it's a good foundation, but it'll be interesting to see where TrueNAS Scale goes. And for now, I think that's what I'm going to do, is I'm just going to stick with that going forward. Now, one final test I want to actually try is to add more memory to this computer to see if it offers any particular benefit. Now, as far as I'm aware, ZFS loves lots of RAM. And it makes sense really, because if you look at the actual diagrams that we were looking at earlier for the likes of the ZIL and the SLOG and how ZFS is working, it's writing data to RAM before it gets sent to the disk. But it also actually uses RAM as a cache. So when you're actually downloading files, it's actually running algorithms in the background to actually cache, the common used files and put them into the actual RAM. That way you'll get a much higher throughput. So 16 gig is the sort of like the minimum recommendation for Scale. So what I'm going to do is I'm going to add in 2 more actual sticks of memory to push this up to 32 gig of RAM. And then just out of curiosity, we're going to see if it makes any particular improvements that we notice. Although to be fair, this is only going to be just single file transfers. It's going to be much better for multiple files, multiple users, that sort of thing. But all the same, be interesting to see if it's worthwhile adding that extra memory. Well, the memory's now been added, and as you can see, we've got close to 32 gig of system memory. Now, the NAS has been up and running for quite a while because I've been playing around and doing some tests because I'm trying to see if I can take advantage of the caching, but the amount of memory that we've got here, which is free, is getting smaller and smaller, which is something we'd expect because ZFS does love memory. Now, part of the reason why we're not seeing a full 32 gig is because the CPU I'm using has got a built-in GPU, and that's deliberate. I'm not going to be using any transcoding on this. It's just intended to be a NAS. So rather than wasting a slot and being able to save power, I don't have a dedicated GPU. The motherboard can actually support a CPU that's got a built-in GPU, and this CPU I've got does exactly that. It supports ECC memory and it's got a built-in GPU, so I can take advantage of the actual video card slots or ports that are actually built into the motherboard without having to purchase an additional graphical card and without needing the extra energy to power it. So yeah, we're using a bit of the system memory for video memory on the GPU for the actual CPU there. Anyway, as I say, I've been having a bit of a play around, and I mean, it's a 15 gig cache that it's got there. And interesting, it does seem to be caching things, and I do quite like that. So that's something to bear in mind, because I mean, in the grand scheme of things, really, we're not really trying to improve single, file transfers here. This is more beneficial to multiple computers, either trying to all send at 1 gig or download at 1 gig. That's the real benefit of 10 gig. But either way, this is quite interesting. I'll see if I can try and repeat it. So if we go to the actual mechanical drives, for example, now I've had to disable the actual sync writes on this because I forgot to do initially, but it's now running just as normal. So we're not actually doing any sync writes within SMB. So there's no actual slog getting used here as we would expect. So I'm going to copy this file and I'm going to paste that. Let's say yes, we'll replace it. Then off it goes. So this tends to vary. So at the moment, by the looks of it, it didn't actually cache that file. So we're getting a reasonably good rate of transfer, I feel. It's difficult to tell whether just adding that extra memory has benefited this single transfer. But what we're going to do is we're going to run it again just out of curiosity to see if it actually gets cached, because I've run it before and I was actually getting over 1 gig download. So run that again. So copy that, paste that. Yeah, early to tell, but you can see it's there you go. So it's obviously been caching it. So I'm back to the similar sort of problem that I have with the NVMe, where it just can't cope, this PC, it can't cope with such high transfer rates. But you can see that obviously once the actual file gets cached, and it obviously takes a while, it's, you're dealing with algorithms. When you've got multiple users, it's going to work out which files are getting cached, which ones are more popular, and it's going to cache them in RAM, and you're going to see your downloads improve a lot. If we go to the NVMe, I don't really expect anything there except the same problem, because, well, this PC was the bottleneck. I just couldn't cope with the download rates anyway. So this is probably going to stutter most of the time anyway. So this was as fast as we could get it to go anyway, to be fair, so the extra memory is not really going to make any difference. There's no point caching this into memory if we can push it off the NVMe quicker than the PC can cope anyway. But it's an interesting comparison. So what we'll now do is we'll flip this over and we'll do some uploads instead. So I don't really expect much here. So we'll copy that and then we'll paste it to the actual mechanical drive. So no, it's not too bad actually. I suppose we've got a bit more extra memory, a bit more buffer to play with, if you will, for the actual write cache. As far as I'm aware, you can actually make modifications yourself and increase that. The only trouble is you're trading off solid latency, and there's also the bigger risk of actually losing data, because if you're putting more data into RAM and the actual computer would have fall over and lose that, you're losing the data. And bear in mind, this is an asynchronous protocol, so you're more at risk of losing data by not actually getting that onto the disk as quickly as possible. So you could increase the settings as far as I'm aware, but it's just that bigger risk of losing the data if the system crashes. So yeah, it's debatable as to what you do. Now, if we go to the NVMe, I'll grab that file again and upload it to the NVMe. So the NVMe itself can handle faster transfers anyway. So you might get a bit of buffering through the RAM and then expect that to go faster when writing to the NVMe drives anyway, to be fair. But yeah, I think it's a tad difficult to tell. I mean, the read speeds are definitely going to benefit for that extra memory, which incidentally, I mean, if you actually have a look at the pool setup, there's an option in there for an actual log drive, a cache, if you will. That's a read cache. But the idea is when it comes to ZFS, TrueNAS, you really want to be populating this with more RAM rather than actual, an actual cache, a read cache. It doesn't really benefit from it, from what I've read, until you've reached at least 64 gig of RAM, and even still, it's kind of debatable as to whether you're going to benefit from having a slower read cache versus a RAM cache. Trying to get as much RAM in here as possible. So I've got 32 gig of RAM. I'd actually be better served by getting more physical RAM than purchasing, say, SSDs or NVMEs to do the caching for me. This system is capable of coping with 128 gig anyway. I don't expect a lot of data transfers on this, to be fair, but if I was in, like a small office environment, for example, throw more memory at it rather than giving it an actual read disk cache. At least that's my opinion anyway, and the sort of stuff I've been reading is that, yeah, the read cache is only really benefit as a sort of like a last resort when you're really pushing your memory to the limits. You're running out of memory options. So I must admit, I really do like this TrueNAS scale. Setting it up is pretty much the same as TrueNAS Core. Operating it is pretty much the same. I'm not really noticing anything different, but it's got more flexibility. It will benefit long term from having that extra memory as well. So the test was definitely useful, I feel, because you could see where it was suddenly starting to cache the file, and it was definitely starting to speed up my read transfers, even over those mechanical drives. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, as that'll help get the video out to more people who might find it useful as well. If you've got any comments or suggestions, please post those in the comments section below. And if you're new to the channel and you'd like to see more content like this, then yes, do subscribe. Just remember to set the bell icon to actually send you notifications when new content gets released, although I also post to Twitter as well as Facebook. If you'd like to help the channel and support it, you can actually make contributions through PayPal and Buy Me a Coffee. I've also got links to Patreon, and there's also the join membership option for YouTube itself. Patreon and YouTube members do have the option to actually benefit from early access as well. But above all, many thanks for watching this video. I'll see you in the next one.